I'd like to introduce Dr. Thorstein Charosky, who serves at the Center of Applied Aeronautical Research in Hamburg, Germany. I do have to say that I remember visiting there a couple times, and I think it was in October of 2016, actually September of 2016, when we first visited Zoll. The facility that's actually behind Thorsten was under construction, and we were talking about the placement of laser peening system. I think we came back shortly thereafter, maybe a year later, and we were able to tour the facility a little bit more and kind of talk about the location of that facility. Thorsten has a lot of experience with various aspects of materials and engineering, and I'd like to introduce him today in his presentation on laser peening. And with that, Thorsten, please proceed.
Welcome everybody to my speech about intelligent strengthening of sheet metal parts by laser beam forming. My name is, as David already mentioned, thank you very much for the introduction, Thorstein Charosky. I'm head of advanced materials at CERIAL, Center for Applied Aeronautical Research in Hamburg. And I will introduce you about how it works in the field of laser shock peening. But when talking about what we are doing, I think it's sometimes a little more easier to understand who we are, what we do, what's our mission, what's our vision, and afterwards I will come to what we actually do in the field of LSP. But then you better understand the context of what we're doing. So as I said, we're not only a research company, so we're an SME with 60 people running a really huge building, CERIAL Tech Center. With our 60 people, we're providing services, knowledge, exchange platform for around 600 other people sitting all in the building, everybody dedicated to research and development. Our shareholders are the city of Hamburg, Airbus and Lufthansa Technik. So you see our main goal is aerospace. We have also the German Aerospace Center, which is a research facility with 4 different institutions sitting inside the CERIAL. We have an association of SMEs coming around the Hamburg area and entire Germany, and also 4 Hamburg universities. As our shareholders, and who is sitting inside of the building, so 60 people from CERIAL, the other 600 are separate to around 30 different other tenants coming from the OEM suppliers, from the high TRL level, I would say, going from the technology partners, providing bricks, technology bricks to bigger developments, and also research institutes, which are on the very low TRL level, going to the middle TRL levels. Then we have the innovation partners, which are sometimes smaller companies or very specialized companies, or facilitators. People are trying to bring the technologies from the research institutes to the industry, to the market. And this is also what CERIAL is doing. We're trying to bridge technologies from the research scale up to the industrial scale. So what we do is we generating ideas, plenty of ideas, evaluating these ideas, screening, monitoring, testing, trying out, coming to concepts, to product visions. It was the most, with the strongest ones and the most advantageous ones. We're going into the software, hardware, prototype development, everything together with partners, with other tenants within the building, to be very close to the market, but having a really strong background in the research and the technology itself. This is where we're working on 8 different fields of technology. So LSP is one of those technologies, but our biggest strength on the one hand is people who are very experienced for many years in the single fields of technology, but also working together with overall the different fields. This means for us, robot-guided additive manufacturing, using a robot for additive manufacturing, improving the rate of automation for laser shock peening. One topic I want to talk about today, for example. So the combination of automation, laser shock peening, also process monitoring, a topic for today, evaluating the pictures, images gained by optical cameras, for example, with AI to optimize the laser shock peening parameters. So the collaboration of these fields is one of our strongest topics and what we are focusing on. So taking the knowledge, combining it with other fields of technology, and bringing this into the aerospace industry together with the tenants all around our building. For us, fatigue damage tolerance, laser peen forming are the two branches we're going in the direction of laser shock peening, but also the process analysis is a crucial point to understand what we did before. This means hole drilling measurements, 3D scans to really characterize what we did before. And so we're working along from consulting, so understanding the process, telling people how this process works, going to the strategy development, testing materials, applications, going into the peening process, to post-analysis afterwards, and setting up demonstrators. We do all of this with the Procuda system from LSPT. As David said, so the system now we're using for 3 years. So we went into service in 2018, and now have a huge chamber for a part size with a footprint of around 5 times 1 meters and up to 180 kilograms heavy. So this is really an industrial. So we want to go into one-to-one scale, having really big parts within the building. But we're starting with tiny parts, getting bigger, and coming to the large parts that are really used in aircraft manufacturing. Around the system, what is our aim? We take the knowledge from research partners, knowledge that's existing already, and transfer it to the industrial scale. This is why we're setting up the Mastercam for an offline programming. We have process monitoring to have a quality control already inside of the process, during the process. We have a metrology system inside of our peening cell to have the scanning of the foreign parts already in the cell to have immediate feedback, and to have a really close loop and make the system more optimized and then faster for the usage, and having a bigger output of parts in this case. And also, as I said, stress measurements. For example, the enhancement of fatigue resistance and damage tolerance. So this is some projects, for example, running together with Airbus. We have a close look on how to improve the lifetime of fatigue. So the very standard things you do for laser shock peening, the deeper compressive stresses you get in comparison to shock peening, for example, the high accuracy, high reproducibility, all things you probably know. But we are focusing also on the automatization. So LSP is a process where we can nearly control everything: loading of the robots, movement of the robots, the path planning. Everything is controlled in advance on the computer with the offline programming. So we're getting control of the entire process chain, the entire manufacturing. The same for the forming, same here. Toolless forming as the big advantage of this technology. But for us, it means we're using this technology for the offline programming, controlling all the single steps to have a flexible production route for forming applications. This as what we do as Serial in general. And now I want to explain with a concrete example how this works for us, what we're doing, and what is the aim of the work we really do. I'm talking now about a funded research project, which is now at the half time, more or less. The problem is the spring effectiveness distortion. You have a manufacturing process of a titanium part, but it doesn't come out of the process as it should. And all the parts coming out slightly different. So you have to correct them every time in a different way. And this is where we need a flexible method to correct those parts. This is why we're using laser shock peening as a flexible production method to correct each part separately. We can analyze all the parts, we can adjust the parameters, we can adapt the scanning strategy and get all the parts in shape. And overall, we can also improve the fatigue life of those mentioned parts. So this project called Peen Core, funded by the Federal Ministry of Economic Affairs and Energy in Germany, has 3 major points for Serial: fully automated process, inline process monitoring, in intelligent data analysis. And this we demonstrate with hot formed titanium sheet plates together with other partners, such as the Helmholtz Centrum at the Leuphana University and Formtech. So the entire process from the deformed part is coming to Serial, and at the end, a finished part is going out of Serial. They're very, very single steps that need a lot of manual work. For example, at the moment, the 3D scan is manual work. The masking and the taping of the metal part is a manual work. Afterwards, the parameter selection, choosing the peening pattern, also the robot programming is shown in the picture. For example, how often some of my colleagues has to go there, adjust a little bit, put some data into the machine, and do the process. So our aim is to take this portion of the process and automate it, so that we only do the masking, bring the part into the cell, and afterwards the finished part is coming out of the cell with the documentation that everything went well. How do we do this? So we have a 3D scanner, a metrology system inside of our peening cell. We do the measurement in advance, and we can do peening directly in the peening cell. We compare scan data and the CAD data, which is already automated. On the basis of the correction that is needed, an automatic LSP strategy elaboration is done. Not only the parameters, but also the path planning is shown in the picture above. What is the best parameters to really adjust the geometry? Then afterwards, everything is transferred to the peening system itself. The peening is performed, and afterwards we go directly into an automated 3D scan again. Then automated scan data and CAD data are compared, and if this is good, then we can go out of the peening cell. Otherwise, there has to be a new automatic LSP strategy elaboration, meaning new parameters and a new path strategy, and then again the peening of the part. And all these iterations, still the works in progress. What should work automated? At the moment, we have already the scanning is automated, scan data and CAD data comparison is automated, and we are working at the moment at the strategy elaboration, which will be the next topic for the following year. And then the data should be transferred to the LSP machine, which then is a conclusive step. But as you probably know, this is probably the most crucial point, especially for the definition of the deformation, the strategy itself is due to the parameters. So where do we focus on the automatic strategy, where to peen first, in which pattern to peen, this conversion into robot paths, and also the selection of the energies, the spot size, the overlap, and all those tools are generated here in this step to really make it independent from the user. So what is the current status at the moment? So we keep with this 3D scan and the masking as a manual step, because we want to really know what is coming inside to adjust the scanning parameters and have a close look at the part. This is why this has been done manually. The masking, of course, at the moment is manually, but we're working on this as well. But then we're coming into the let's say automatic box, then parameter selection, peening pattern program about to optimize at the moment, but this will take some time, probably the next year, as I already said. Peening process here, well, the peen process already is automatic, but to get the parameters into the peening process to the machine, this is one point, this is open, but the process monitoring is already installed and working, and the 3D scan is also working. So we have now all the possibilities to make it automized, but we still have to work on the data that is transferred and to have the data at the right point. This brings me now to the conclusion that we now have a monitored system. And the monitoring, for me, is a very crucial point, because I don't want to test all the parts, because all of you know that you normally have destructive testing to really know what residual stress you have. Even with hole drilling, you have holes everywhere you test. So I want to know inside of the process if everything went well. And if I have a part already tested and know that if all parameters are good, that comes out well. So I want to monitor all these parameters. This is a very crucial point. The next step is the automatization of the workflow. This is still in progress, but we're making big steps to really make it run and to make the system working on its own. So we have a highly technologized and automated laser peening cell at CDL, still operated, but working on it to have the peen forming, but also for the fatigue improvement. So what are the outlooks? What is coming next? We're using all the digital tools we have to really make it an intelligent process. So knowing what happens during each step. If we're getting better, also during each shot, analyzing each shot, having a okay or not okay, and then going through the entire process or adjusting the parameters in between, so we get a good part out of the process. So we really can apply it on complex shaped parts, individual parts, such as 3D printed parts, for example, and also large components on an industrial scale. This is our aim. This is what we want to go for. This is where we see all the future for the laser shot peening. So this is for my talk so far. If you have any questions, feel free to ask now or write me an email. But it would be great to have some discussion now if you want or have a question.
Yeah, thank you, Thorsten, for your presentation. I greatly appreciate it. The floor is open for questions. We'll take at least 1 or 2 questions, and I'll kind of monitor, see if somebody raises their hand. I'll go ahead and ask the first question. You talked about the automation, and I guess I was kind of curious from your perspective, how far out do you think that automation effort is in terms of being implemented? Is that a few years or is it longer than that? I think that's probably an important part for getting the technology into production.
Yeah. So I mean, we're not the only ones working on this topic, right? I think it's going to be pretty fast, I would say. So I mean, you in your old facility, you had a nearly automated production line already. So we're now trying to get in a slight different way. I think the next year, the next 1.5 years, we should have all the digital tools ready to make it being optimized. And then we have to make sure about the data transfer, how the machine gets the right data. And but I think in the time frame of 1.5 years to 2 years, it should work out.
Okay, great. I don't see any other questions that have come in at this point. As Thorsten had suggested, if you have more questions, you're welcome to reach out to him via email.